ultrasonic inspection of welds, but there's a backing bar. Let's take a look. First off, the shirt that I've got on is the NDT Hero shirt. This is from Eddie Pompa. Eddie is really passionate about the NDT industry. There's some cool stuff on the back, all this great comic stuff, theme for NDT. I mean, what a time to be alive. So I'll put the web link right here and you can get a shirt for yourself. I'll use this weld right here. This is a weld test coupon. It's 1/2 inch thick with a single bevel, backing bar on the bottom. And we're going to talk about 3 things about backing bar weld inspections that can make them challenging and maybe even easier. And we won't do it with phased array. I know every video seems to have phased array in it. We're going to actually do it with conventional UT today. I'll use the Sonotest Wave on Olympus 5 megahertz 70-degree transducer. And we'll use this ruler from Australia, which has both millimeters and inches on it. But today we'll use millimeters because Canada and Australia, they're like this. Okay, first up, number 1. It's the backing bar signal. It's that annoying thing that shows up on your screen, and it's the sound that goes through the joint at the bottom where the actual weld metal is fused to the backing bar. The sound gets in there, bounces to the end of the backing bar, comes out, and you see a great big huge glob on your scan. We know that's the backing bar signal, and I'll tell you how we do. We move the probe sort of down to a position where I've got a nice signal. There's nothing really in the way. I'm before these 2 flaws on the plate. I'll hit freeze, and you can see at the top of the screen, it says gate 1 peak, surface distance minus X. Okay, so I've done the X offset or measured the beam index point on the wedge. So now everything is measured to the front of the wedge and not to the beam index point. So we put that probe back where it was, and I measure about 40 millimeters over. That takes me way over here, kind of next to this little rust blob right there, okay? So if I take this, you can see that position lines up with the end of the backing bar. Another thing is that when they put the backing bars on, they usually put these tack welds to hold them on. When you are doing the inspection, you'll oftentimes see those signals. See the backing bar signal dip right there in the middle of the plate? So you're going to see that effect as you're scanning the length of the backing bar. The second thing about backing bar welds, and I actually think this makes them easier to do, or at least easier to position your transducer and know where you are, is the fact that when the weld fuses to that backing bar, on the far side of the root, you do get a nice reflector. So you can tell immediately where you are. You may not get this on a piping weld because the amount of penetration that you get on the bottom and the amount of root cap is not really going to be that consistent on the piping weld. But when you have the backing bar, you do have that one location where you should get a little bit of sound off of it. You can demonstrate that here, just moving that back and forth. That's pretty easy. That's that one that's lining up right there at that first line. So that's the ID or the back wall. And you can see that as I go down the length of the weld, it's always kind of there. This helps us position the probe knowing where we are. So you know that if you push the probe forward enough and you get that signal to kind of line up at that first line on your screen, your leg line, then you know that you've gone down to the root of the weld on the first leg, and then simply just oscillate the probe and pull that back in order to get your full 2-leg inspection. Number 3 is the fact that on backing bar welds, we're oftentimes looking at a single bevel weld. In my experience, we usually have one plate which is prepped completely flat, and the other side is prepped, say, at a 30 or 45-degree angle, and sometimes there can be a really big root gap. Because of this, it becomes difficult to define the center of the weld. If you're doing piping or pressure vessels, where a lot of the time it's just a V, then you look at the cap and you sort of draw a line down the middle of the cap and you say, that's the middle of the weld. That's not the case on a single bevel weld. So I find it easier on welds like this to measure everything from the unbeveled edge. You can see here on my scan plan that that indication lines up right there at around sort of the 8 millimeter mark from the edge of that unbeveled side. So if I put the ruler down right here, you can see it's pretty much right on. That's 3 really quick things about backing bar welds. Again, when I started, I found them really complicated. And then as I got further and further on into UT, I actually got really used to them. And I actually really like the fact that there's some repeating, recognizable geometry signals in there that make it really easy to know where you put your probe without actually even looking at your fingers. I hope you enjoyed the video. If you did, please hit the like and subscribe buttons, and thanks for watching. Good night, sweet prince.